Hi Year 11, in this video we are going to look at tests for negative ions. There are three different methods we're going to look at. The first we're going to look at is how to identify carbonate ions in a substance, then how to identify sulfate ions in a substance, and then how to identify each of these three halide ions in a substance. So the carbonate and sulfate are both polyatomic ions, where we have a compound molecule with an overall charge. So, carbonate first. Let's look at the equipment we're going to use. So, we have lime water, we have hydrochloric acid, we have a delivery tube, and we have our sodium carbonate. So I've already added sodium carbonate to my test tube, and I have lime water in my boiling tube. So, I've got my colourless lime water, and I'm going to add my hydrochloric acid to my test tube, and hopefully I'm going to see fizzing, and there's going to be production of gas that should bubble through the lime water in my boiling tube. So it's quite difficult, quite tricky to do this and get it to, there we go. So we can see that we've got bubbles going into the lime water, and hopefully you can see that the lime water has actually gone cloudy if I give it a little wiggle. So I've got my fizzing going on in my test tube where I've got my acid reacting with my carbonate, and then in my boiling tube I've got my lime water where I've bubbled the gas through and it has gone cloudy. I'm just going to add a bit more acid to my carbonate just to see if I can get any more of it reacting, and it does seem to have gone colourless again, which can happen, but it did initially go cloudy, which was the main thing. I might just do that again just to show that for sure that's what's going on. So add my lime water. You don't need very much lime water. In actual fact, the smaller amount you have, the better. I'll add a little bit more carbonate and then a bit more acid. There we go, bubble that through, and we can see hopefully that that's cloudy and not colourless. Okay, if I keep it in there, add a bit more acid, because I did add a bit more carbonate, you can see much more rapid bubbling there and definitely gone colourless. Okay, leave that there. Now Year 11, we're going to look at the test for the sulfate ion. So in my three test tubes, I've got copper sulfate, sodium sulfate and iron sulfate. And just by the names of them, we know that they all contain the sulfate ion. So what we're really doing here is just trying to prove that we have the sulfate ion present. Now, what I want you to also consider is that we actually doesn't matter that we've got copper, sodium and iron, because we're not testing for metal ions, we're just testing for the sulfate ion. So the first thing that I need to do is add a little tiny quantity of hydrochloric acid to each of my test tubes. This acid removes any carbonate ions that could be present, because carbon dioxide is always dissolving into any water that could be around. So this is just to remove any carbonate ions, as that would potentially give a precipitate, which we don't want to see. Okay, so 1, 2, 3, 4, 6, 1, 2, 6. Okay, so that's my acid added. Now, the thing that's going to show us whether we have sulfate present is the addition of barium chloride. So I'm going to add about 1 centimetre cubed of barium chloride to each of my test tubes. Doesn't have to be that accurate. So a centimetre cubed there, centimetre cubed there. Notice I'm not touching the sides of my test tube with my pipette so that I don't contaminate my barium chloride, and a centimetre cubed there as well. So what we need to do now is actually just let any precipitate that has formed settle at the bottom. So at the moment, each time we have actually seen a precipitate forming. Now, we also need to be aware that the copper sulfate initially was blue, and we shouldn't let this taint our identification of the precipitate. So sometimes it's not very easy to see, but we need to let it settle a little bit more. These two are very obviously white. Okay, the sodium sulfate is colourless in the first place. The iron sulfate's slightly yellow in the first place, but these aren't anything to do with the sulfate ion itself. So when we're reacting barium chloride with each of these solutions, I want you to think about what the product is. In each case, this is a precipitation reaction, so essentially the barium from the chloride is swapping places with the metal in the sulfate. So we should be ending up with copper chloride, sodium chloride and iron chloride, all of which don't produce a precipitate. Therefore, the precipitate we are seeing is barium sulfate. So because we've added barium chloride, in each case we've got barium sulfate, and barium sulfate as our other substance being formed, which always forms the same colour precipitate, which is white. It's not very easy to see, there is still that blue tint, but if we'd left it for long enough we would see the precipitate settling at the bottom and it would be white. That's already white, we can see that at the bottom there, and this is also the white precipitate of barium sulfate. Now for the final tests for halide ions. So we're starting over here with potassium chloride, potassium bromide and potassium iodide, which are all solutions of potassium halides. So what we're going to do is carry out the test to prove whether we've got chloride, bromide or iodide ions present. Now we obviously know which one is which here, that's the whole point, but if we had an unknown substance then we could carry out this test and identify which halide ion was present. So in order to do this we need two reagents. We have nitric acid, which is added in the first place to neutralise our carbonate ions, and then we're going to add silver nitrate, which is going to show us which halide is present. Notice the silver nitrate is in a brown bottle and it reacts with UV light, so it stains skin and it stains desks and all things like that. Okay, so starting off, going to add my solutions to my test tubes. Just need about a centimetre cubed, about the same amount in each. Just going to add literally a couple of drops of nitric acid. Okay, I'm going to move that out of the way. And then we're going to add our silver nitrate next. Okay, so we can already see that we have distinct colour differences between each of these. So if I move the camera a little bit closer and just refocus for a moment. So we can only really tell the difference if we actually look at them all together. and sometimes it's best to do that against some white paper. So if I hold that up against there, then we should see this is white, this is cream, and this is yellow. Those are the colours that you need to learn, okay? So the chloride ion shows up as a white precipitate when it reacts with the silver from the silver nitrate. The bromide reacts with the silver nitrate to form silver bromide, which is a cream precipitate, and the silver iodide is a yellow precipitate. So those are the colours that you need to learn. So Year 11, on the board I've got the results of these 3 tests that we've just been looking at. So the carbonate, when we react it with acid, forms a salt and carbon dioxide and water, and it's the carbon dioxide which turns lime water cloudy, and that is the confirmatory test for carbonate. For sulfate, we add a little bit of acid first, and then barium chloride, which forms copper chloride, which is the blue solution, and then barium sulfate, which is a white precipitate. With the other 2 sulfates we tested, we would get the metal chloride plus barium sulfate in each case, always forming a white precipitate. And in the final test, for our halide ions, we reacted it first with a little bit of nitric acid and then with silver nitrate in each instance, forming a silver halide, so silver chloride, silver bromide, silver iodide, and always potassium nitrate. And it's these 3 compounds which form our different coloured precipitates: white, cream, and yellow. Thank you for listening. I hope you've enjoyed the demonstrations of these tests for negative ions.